Welcome. Welcome in Great Room. So this session we're having Thomas. Thomas will talk about QEMU parameters jungle. Thomas, the stage is yours.
Thank you. So hello and welcome to my talk. My name is Thomas Huth. I'm working for Red Hat and I'm a QEMU developer since more than 5 years now already. So working with QEMU since a couple of years already. Of course, the first question is there a need for a guide through the QEMU parameter jungle? I'd say yes. QEMU is a very big project. It supports a lot of guest devices. It supports a lot of host backends. It's been in development since approximately 15 years now, so there's a lot of legacy code in there, and of course a lot of legacy command line parameters. And if you just have a look at the help output of QEMU, it already has more than 450 lines of code. 450 lines, and especially I regularly see people asking on the mailing list and on IRC about how do I start QEMU to get this and that done. And so I thought it would be a good idea to maybe explain some things. One thing in advance, if you just want an easier way to run a virtual machine, try to use libvirt, Virt Manager, OpenStack, or any other upper layer tools. Instead, they can make your life much easier. But if you're interested in running QEMU directly, this is hopefully the right talk for you here. So general know-how. I hope everybody knows what QEMU is. Is anybody in the room here who does not have a clue about QEMU at all? Okay, that looks good. Who ever tried to run QEMU directly already? Okay. And whoever wondered, how do I use these parameters to get the things done that I wanted to do? Okay. So pretty much everybody who tried to run QEMU also had some problems with that already. Okay, so let's get started with some general know-how. First thing to notice is that QEMU does not distinguish between single dash parameters and double dash parameters like most other GNU tools are doing it. So dash help is exactly the same as dash dash help. Then you've got to be aware that QEMU is running the guest with a set of default devices. So each normal guest has a network interface card, for example, a VGA card. And sometimes there are cases you do not want this. You rather want to start with a blank board instead. And in this case, you should use the dash no defaults option. And this will disable almost all of the default devices. And there's also a way to suppress just certain default devices, for example, dash VGA none or dash net none to disable the VGA card or the network interface card. Getting help about the command line. Of course, there's a man page, and we also have a pretty long HTML help text for QEMU, which explains most of the thing. But if you're just sitting at the shell and want to get some help about the parameters, you of course can run it with dash help to get a rough list. But the important thing to know is that you can also run a lot of parameters with the string help too. So for example, if you run QEMU with dash x for help, it will print you a list of available accelerators like KVM, Xen, Hexen in the recent QEMU releases. And this is especially helpful for the dash device parameter. Dash device is the parameter that you use to add an additional device to the guest, so additional hardware like network card. And so if you run dash device help, QEMU will print out a nice list of available devices for the guest. And if you've chosen one of the devices that you want to add, you can also run a dash device parameter with the device name, comma help, and it will print you out a list of parameters that you can use to configure the device. So here's an example for the E1000. The E1000 is a network card. And I run QEMU with dash device E1000, help, and I get a nice list of parameters that I can use to configure the network card here. So, for example, a PCI slot address, or I can set the MAC address of the network card. And once I've picked the parameters that I want to set, I can run QEMU with dash device E1000, MAC equals the MAC address, comma, address equals the PCI slot and function. Any questions?
It says in the help text that address is an int32 parameter, but 06.0 is not
So the question was that address here should be an int32. Actually, that's a good question. Yeah, maybe it's just. I never noticed this. Yeah, you're right. It should be an integer, but you can really set a PCI slot and a function number. So it's slot dot function number in this case. I've got to look it up. That's a good question. Thanks. Next thing that you should really be aware of is that a QEMU device consists of two parts. So at one side there's the emulated guest hardware, like the network card itself, and the other part is the host backend. So the hardware in the guest has somehow to interact with the outside, and this is the host backend. For example, a E1000 network card could be attached to a tab host network via a bridge to the outside. I explicitly say it here because a lot of people get this wrong. They just think, I want to run QEMU and I want a network card, so there must be one parameter that gives me everything. But that's often not the case, especially if you want to have full control over the system. If you want to do it correctly, you've got to normally specify both. Dash device to configure the guest side and another parameter to configure the host side. And this leads us to the next slide. You also got to be aware that there are different classes of QEMU parameters. So the first class are, you could say, the convenience parameters. And these convenience parameters often give you both in one parameter. So for example, dash CD-ROM, and then you can give an ISO file image name, will add a CD-ROM device hardware to the guest side, but it will also configure the host backend, and the host backend in this case is just a block layer module that reads the ISO image on your host. Then there are the architected options, and these give you now the full control over the QEMU internals. And here normally you have to specify both sides separately. So for example, to configure a CD-ROM drive, you would say dash device IDE CD for configuring the guest hardware. And to configure the host backend, you would use blockdev raw, and then you can also specify the ISO image on your host somewhere. Yeah, there's a question.
The minus blockdev, is it a typo, or do I have to be careful with double and single dash?
I mentioned that a minute ago. Oh, the question is whether this dash blockdev is a typo or whether it's on purpose. So QEMU does not distinguish between single dash and double dash. So in this case, I was just lazy because the line got very long and I do not want to reach it into the jungle leaves here. But yes, it's a little bit ugly that QEMU does not distinguish this. But yeah, once you introduced it, you have to stay compatible with all the versions, so you do not want to switch. And yeah. A third category are simply legacy options. So as I mentioned, QEMU is a very, very old project with 15 years already. So there are a lot of options that have been introduced in the past, but simply do not match the current internals of QEMU anymore. But the QEMU project normally tries to stay as compatible as possible with all the releases. So there are a lot of old options around. And for example, for the CD-ROM example, you could, for example, use -drive IF for interface equals IDE, comma, media equals CD-ROM, and then you can also specify the ISO file name on your host. So that was just the introduction. Now let's look into the different classes of devices a little bit closer. Let's start with character devices. And character devices, you configure the host backend with the -cardef parameter, and you can list the available host backends with -cardef help. So for example, I can map a character device to a file on my host. I can map it to a socket, standard I/O, pipe, GTY. There are lots of more options. If you're interested, just have a look at the QEMU documentation. So, for example, to redirect a serial port of the guest to a file on the host, you could run QEMU. In this case, I started with no defaults because I want to avoid that QEMU configures a default serial port. And I also do not want a VGA card in this case. I explain why. And then you say -cardef file, and you have to give it an ID, identification string, in this case C1. And with path equals the file name, I tell QEMU which file to use on the host file system. The guest hardware is configured with -device. ISA serial is a serial port on the ISA bus. And then I say, comma, cardef equals, and here's now the ID to tell QEMU which character backend should be used to connect the serial port to. And actually, if you run this command with a recent version of QEMU, you will even see something in the file already, because the recent version of QEMU, they ship with a guest firmware that can redirect its output to the serial port if no VGA card is available. So since I started QEMU with no defaults here, you would see the output of it's called CBIOS in the text, which is quite neat. So for character devices, there are also some legacy, or you could also say convenience options. Sometimes you cannot really distinguish between legacy and convenience because because the old options are often way easier to use than the options that give you full control. So some people say they are legacy, some people say they are much easier to use, we should keep them forever. And in this case, there's, for example, -serial and -parallel for configuring serial and parallel ports. And these also configure both the host backend and the guest hardware in one go. And I sometimes use -serial because it's really convenient. For example, you can use it if you want to emulate an embedded PowerPC or ARM board, which outputs which prints its output to a serial port, and you have to run it with no defaults for some reason. You can use -serial mon standard IO, and this is a special mode that multiplexes the so-called QEMU HMP monitor with the serial output. And you can then toggle between the serial output and the monitor with the keyboard shortcut Control A, C. I'll try to show it. So this is the command line here. I'm using embedded PowerPC board. Run it with no graphics because I'm a console guy. I do not want this fancy GTK window. For some reason I want to run it with no defaults, and then I say serial mon standard IO, and here it is. So you see the serial output of the guest. In this case it's the U-boot firmware, and I'm talking here to the U-boot. Can, for example, run the help text and I get the U-boot help. And at one point in time I say, oh, I want to talk to QEMU instead. So I press Control A, C, and you end up in the QEMU monitor. If you now type help again, you get the help output of the QEMU monitor instead. And there you can do things like a system reset, for example, and you see my PowerPC guest just started again. So, of course, I can also quit the system. Okay, that's all for character devices. Let's have a look at network devices. So modern network devices should be configured with the so-called -netdev command to configure the host backend side. And just as with the character devices, you first have to give a type and an identification string. And the type can be, for example, a user for a fully emulated network stack, which is quite nice because it does not require any privileges or a special bridge setup on the host, but it's a completely network address translated network. So by default, you cannot reach the guest from the outside. You have to do things like port forwarding. And of course, if your TCP traffic has problems with network address translation, then it's also not that good. So for having more control over the network, you normally want to use the TAP device, which gives you real network access via a bridge. And there are also some other options, like, for example, a socket which can be used to tunnel all the network traffic to another instance of QEMU if you just want to hook up to virtual machines, for example. The example looks somewhat similar to the character devices here. So I specified a host backend, in this case a user network with an ID N1. And since the user backend is a fully emulated network, QEMU also provides an emulated DHCP server here. And you can, for example, configure the DHCP server with a parameter like DHCP start and then the starting address of the IP addresses that should be assigned to the guest. The guest hardware is configured with -device again. In this case, I'm not using the E1000 network card. I'm using the VirtIO network card, and I use -netdev equals and here the ID of the backend to say to tell QEMU which host backend it should connect the guest hardware to. Of course, there's also a legacy network command, and this is the -net command. The -net command can be used to configure both the guest hardware and the host backend, but not in one line. You have to specify it twice. So with -net NIC for network interface card, model equals the type, for example here E1000. You configure the guest hardware, and the host backend part looks similar to the -netdev on the previous slide. So -net user configures a user backend for this. The thing is that you also have to connect these two parameters together, and this is done via the so-called VLAN equals number option. In this case, I set VLAN equals 0, which uses the VLAN with number 0. 0 is default, so you can omit VLAN equals 0 if you just want to use that one. You just have to specify it if you want to use another number. Now the confusing part. VLAN is not what you think of when you hear the term VLAN. Normally, VLAN is network traffic encapsulated in some other network packets, not in QEMU speak. In QEMU land, a VLAN is, you could think of a emulated hub. So just replace the term VLAN with hub in your mind, and then it's pretty much what you get. You see, the -net option is quite confusing, so I recommend to use -netdev if possible. You just have to be aware that there's still one case where you need -net, and this is if you want to run an normally just try to use -netdev instead. So to really give you a vision of what I'm talking about, I've drawn some nice pictures here. So -netdev gives you a real one-to-one connection between your guest hardware and your host backend. For example, here I want to run a guest with 2 network cards, and thus also with 2 host backends. And the first one is an E1000 device connected to a user netdev, so connected via the ID. And the second one is a VirtIO net connected to a tab host backend with N2. And in this case, you really get straight connection between your that's a typo, should be E1000 and the user, and the VirtIO net to the tab. Just that's normally what you want. Now, if you try to do the same, and I often see that on IRC and on the mailing list, if you try to use the net command, like you can also see it in some very old examples in the internet on some third-party pages. People often try to use -net nic model something, -net user, and then the second network connection, they just do it again, -net nic model, in this case VirtIO, -net tab. And in this case, I omitted the VLAN equals number option on purpose, because this is what people often get wrong. In this case, you get a hub in between. So everything is connected to an emulated hub. So the traffic of the E1000 network card is also visible on the VirtIO network, VirtIO net network card, for example. And of course, it's somehow working because people normally do not look very close at the traffic yet, but it's not what you really want normally, unless you really want to sniff the network traffic on one interface to see what's happening on the other interface. So, if you really want to use -net, you have to use VLAN equals number parameter, or try to avoid it and use -netdev immediately. Yes, there's a question?
If you wanted to set something like this up, you did want to mirror the traffic to monitor it or something, can you achieve that using netdev as well, or do you have to if you want that hub thing?
Yes, there's also a way to connect netdev to a QEMU hub. But actually, if you just want to sniff the traffic, there's even... Oh, sorry. The question was, if I want to sniff the network traffic on one of the interfaces with the -netdev command, you can do that. There's also a way to connect netdev to a hub since a couple of weeks at least. But actually there's a better way to sniff network traffic. QEMU can sniff the network traffic for you. There's an option to dump the network traffic into a file, in the same file layout as used by Wireshark and TCP dump. And then you can just let QEMU dump the traffic into the file and look at it afterwards with Wireshark, for example. So let's have a look at the third category, block devices. Modern block devices should be configured, maybe you guessed it already, with the -blockdev parameter. Now, I see a couple of people looking strange. So blockdev is quite new. Blockdev is only there since a year or two, I think since QEMU 2.9 or something like that. But that's the way to go. So in this example, I want to start my graph with an QCO2 image. So QCO2 is the native image format of QEMU, which is the preferred one, of course. And as you already see, I specify here blockdev twice. So the block layer of QEMU is quite complex, and you can stack the different block layer drivers on top of each other. So this works like this. So I specify a blockdev file driver, which connects to a raw file on my host. In this file, in this case, the img.qco. I give it a node name, so this is pretty much the same as the ID equals something, as you've seen in the previous examples, but with blockdev, its node name equals f1 in this case. And the file driver just gives me raw access to the file. On top of that, I have to specify a driver that handles the layout of the file. So this could be QCO2, VMDK, something like that. So I specify another blockdev driver, in this case QCO2, give it another node name, and I say connect to the raw driver that I specified just before. And then I can connect my guest hardware, in this case an IDE hard disk, and say drive equals the QCO2 driver, and this way I connect it to the QCO image. If that's too much to type, there's also a shorter way where you can specify everything in one line. So in this case, you immediately start with the QCO2 driver, give it a node name, and then you can say file.driver equals file. So this is the raw driver in the same line, and file.filename equals img.qco, and also connected to the IDE HD guest hardware. And you see already this is quite complex, but this gives you the full control over the QEMU block layer stack. So if you've seen the presentation of Kashyap this morning, you maybe also got already the sense that the QEMU block layer is quite mighty. And this is an example for what is possible with the block layer today. So the IDE hard disk guest hardware, in this case, is connected to a raw block driver, which again connects to a so-called quorum block driver. And the quorum block driver can query multiple other sources. For example, one is in QCO2, which is then connected to another block debug driver, and finally the block debug driver is connected to a file on your local host. But QEMU can not only connect to files on your local host. So this QCO2 driver has a backing chain, for example, to another QCO2 driver, which connects via HTTP. I think it's using curl, libcurl inside. So it can also access files that are somewhere on an HTTP server, for example. And this way you can really set up complex trees in your QEMU command line parameter jungle. Question?
How about this quorum node? Is it a kind of a local answer or what?
The question is what the quorum driver is. I think, actually I've never used it. So I think it just queries multiple sources and uses the Or maybe Stefan can answer that one.
Yeah, so it can do a few things, but the main idea is replication. So you can take one block that's being written by the guests. So the question is, what does Quorum do? It can do a few things, and the main feature is replication. So say you have 3 NFS servers, and if one of them goes down, your VM could keep running, because what the Quorum driver does is it will actually read from all 3 of them. It will compare and make sure that the disk image is still consistent, and then it has rules for repairing.
Is that used for high availability?
Yeah.
Yeah. So, as also mentioned here at the bottom, the slide has been taken from another talk from KVM Forum 2014 by Max Reitz and Kevin Wolf. So if you are interested in the QEMU block layer, I can recommend that talk, and also there are some other talks, for example, from Markus Armbruster a year earlier, something like that. I've got some references on the last slide for that. Of course, block layer is complex, so there's also a legacy option, and this is -drive. And since -blockdev is still quite new, you see -drive still in a lot of examples in the internet. You can use -drive to configure both the guest hardware and the host backend in one line. For example, to set up an IDE drive, you would say -drive IF for interface equals IDE, format equals raw, could also be QCO. In this case, just give a raw file, and then file equals file name on your host. There's also a special case here where you say IF equals none, and this was used to only configure the host backend side. And this was mainly used before the new -blockdev command was introduced into QEMU. So if you are using a recent QEMU, try to use blockdev instead. If you are using an older version of QEMU, you likely got to use the -drive with IF equals none. -drive is quite complex and does not really match the internals of QEMU that much anymore, so be aware that parts of -drive might be removed in the future. Do not use it in new scripts and code anymore, in the upper layers if possible. And of course, there are also some convenience or even more legacy options. For example, if you just want to use a hard disk image on your local file as any kind of, or in this case it's an IDE on the x86 platform, guest disk, you can use -HDA, for example. -FDA is used for floppy drives, and -CD-ROM for CD-ROM drives. You had a couple of these already in the past slides. And there are many more of them. So, this is all I wanted to say in a short amount of time here. And you could, of course, talk forever about QEMU parameters, I think. Just a couple of points I wanted for you to take away. So, if you run QEMU, try to be aware that there are always 2 parts, the emulated guest hardware and host backends. And if you want to have full control over both parts, you also got to specify each part separately. By using the -cardev, -netdev, and -blockdev commands together with the -device. And in scripts and other code that should be future-proof, please avoid to use -net and -drive, since these are really legacy and might get removed in the future. We do not have concrete plans for doing that yet, but the discussion pops up every couple of months, you could say. Yep. So the comment is that libvirt, for example, also still uses -drive and did not switch to -blockdev yet. So it won't happen very soon that we really can get rid of -drive, but I think people are working on that. So that's all I want to say. Thanks for your attention, and yeah, questions. I think you were first.
So you said that sometimes the convenience options and legacy
Yeah.
Will, I assume they will, the to-be-deprecated one will be clearly marked then, so which ones are future-proof, or is it already done?
So the question was that the legacy and the convenience options are sometimes hard to distinguish, and whether we or how we remove or when we
Already marked as deprecated.
yeah. Options that we intend to remove, they are clearly marked as deprecated. So if you run QEMU with such an option, it normally prints out a line at the start. This option is deprecated. Please use something different instead. And we've got a chapter in the QEMU documentation where we list all the deprecated devices. So some options like dash drive, for example, they are considered somehow as legacy, but they are not deprecated yet, so they won't get removed very soon yet. I just want to say that you should be aware of it, that in maybe 2 or 3 years they could be marked as deprecated, and then a year later maybe they are removed or something like that. Yes, please.
So I was always wondering, with that many options, and I'm not sure, maybe I have missed something, why not have a configuration file?
Yeah, there is a configuration file, but so the question was, we have so many options, why don't we use configuration files? You can use configuration files, but they are not, for some reasons they are not that popular. Actually, you cannot do everything with a configuration file, as far as I know. So not every command line parameter really works from the configuration file. And people are not using it that much, actually.
Some hosting providers seem to use that as well, but Marcus Ambuster, another block-layer developer, maintainer, said there's only 60% mapping of what's available for configuration file.
No. So the comment was that some hosting providers apparently are using the config options, and only a percentage of the configuration of the command line parameters are really working right from the configuration file. So.
People wanting configuration files just use libvirt.
Yeah, that's also true. So the comment was that people who want to use configurations files, they just use libvirt. Yes, please.
In other places there are IDs or node names to connect the host against configuration. Are there any limitations on what you can use for those IDs? So maximum length or characters?
So the question was, for the parameters that use these IDs or node names, are there any limitations in length or characters? Actually, I've never tried. I don't know. I guess there are some limitations, but apparently people did not try to hit them yet. Sorry. Yes, please.
You were mentioning this dumping, sniffing the traffic via QEMU as separate parameters and dumping it to as a file. Will it really be feasible for all networking backends like this vhost user when you have DPDK? So actually QEMU doesn't have the access to the data plane traffic, according to my kind of understanding.
Very true. So the question was, I mentioned this possibility to dump the network traffic, that QEMU can also dump the network traffic. And the question was, what about then the host backends like vhost user that somehow bypass the QEMU networking stack? And you're right, for these backends you cannot dump the traffic this way. So this only works for the normal case where the network traffic is fully handled by QEMU. Okay, time's up. If you have more questions, just catch me outside. Thanks.